In section 5.2, adding and subtracting polynomials, our objectives are to know the basic definitions for polynomials and add and subtract polynomials. For the basic definitions of polynomials, we want to first look at terms. Examples of terms include negative 3x, 2/3 x to the fifth, or 2k to the fifth over 3, 8x to the third y, 6 divided by 7m squared, and 21. All the coefficients of those terms are written in blue. Now, a polynomial is a term or a finite sum of terms in which all the variables have whole number exponents. And also there are no variables that appear in denominators or under radicals. So negative 3x can be a term in a polynomial because the exponent is a whole number. 2 over 3k to the fifth can also be a term in a polynomial because the whole number exponent of k to the 5. Now, the term 6 divided by 7m squared cannot be part of a polynomial because the variable appears in the denominator. So that would not be considered part of a polynomial, although it is still a term. A polynomial in one variable is written in descending powers of the variables if the exponents on the variable decrease from left to right. Now our polynomial listed here has powers of 4, 3, 1, and 0. So we say that's written in descending order, although x to the 0 is 1, so it's not necessary to write that last term with an x to the 0 power. You can simply write it as the constant term, and this is written in descending powers. The degree of a polynomial is the highest degree of any of its non-zero terms. So let's look at the first polynomial example, 9x squared minus 5x plus 8. The highest degree of any of its terms is 2, so the degree is 2. In the second example, 17m to the 9th plus 18m to the 14th minus 9m to the 3rd has a degree of 14 because the largest exponent is 14. The third example, 5x, has a degree of 1 because the exponent x for x is x to the first. It's understood to be 1, so we say that that 5x term has a degree of 1. The next example, negative 2, has a degree of 0. And the reason why is that negative 2 can be written as negative 2x to the 0 power. So remember, the degree is the highest degree of its non-zero terms, the highest exponent of the variable term. The next example, 5a squared b to the 5th, has a degree of 7. And to find that degree, you add the exponents, 2 and 5, to get 7. The last example, 13xy to the 4th plus x cubed y to the 9th plus 7xy. This has a degree of 12 because if you add those greatest exponents of 3 and 9, you get 12. Some common polynomials are given special names. For example, a trinomial is a polynomial that has exactly 3 terms. A binomial is a polynomial with exactly 2 terms, and a monomial is a polynomial with only 1 term. And here are some examples. For monomials, examples are 5x, 7m to the 9th, negative 8, x squared, y squared. Those are all considered monomials. For binomials, we have a polynomial that has 2 terms. The examples are 3x squared minus 6. That's a binomial. 11y plus 8. And 5a squared b plus 3a. Those are all examples of binomials. Trinomials are polynomials with exactly 3 terms. So here's an example, y squared plus 11y plus 6. That's an example of a trinomial. Notice it has 3 terms. And the other 2 examples, 8p cubed minus 7p plus 2m. This is a trinomial. And then the last example here for a trinomial is negative 3 plus 2k to the 5th plus 9z to the 4th. It's a polynomial with 3 terms. On the bottom of the slide here, we have some examples of other types of polynomials. This polynomial has 4 terms, so we don't give it a special name. We just say that it's a polynomial. And this polynomial has 5 terms, so we don't give it a special name. We just call it a polynomial. When we are factoring, often we are factoring out monomial factors. We are often finding factors written as binomial terms, and a lot of times we'll start off with trinomials and we want to end up factoring those. In this example, we are classifying the polynomials. I identify each polynomial as either a monomial, a binomial, trinomial, or none of these. In example A, we see the polynomial is negative x squared plus 5x plus 1. Since this has 3 terms, we classify as a trinomial. In part B, the term is 3/4 xy to the 4th. It's a single term, so we classify that as a monomial. And the last example, part C here, has 4 terms, so we don't give it a special name. We could say it's none of these. We can say that it's simply a polynomial. We can add and subtract polynomials. Addition of polynomials is just a matter of adding up like terms. For example, consider the following polynomials: 6x squared minus 8x plus 7 and 5x squared plus 5x minus 6. We can add the polynomials together. The first polynomial plus the second polynomial is found by adding up the like terms. The first like term, we're looking at 6x squared. In order for you to add the other like term to it, it must have the same variable with the same exponent. So the like term is 5x squared. You can add those together. We also add what we call the linear terms. The next term is negative 8x, and the other term, the like term, must have the same variable and the same exponent, and that is 5x. So we can group those together. And then to add up the constant terms, we have plus 7 in the other like term. The other constant is minus 6, so we can add those together. So by grouping and combining like terms, we can add polynomial equations and end up with another polynomial. So 6x squared plus 5x squared, we add the coefficients 6 and 5 to get 11x squared. For the linear term, we have negative 8x plus 5x. We add the coefficients to get negative 3x. And finally, the constant term 7 minus 6 is 1. So we end up with a trinomial. In this case, the first trinomial plus the second trinomial gives us a third trinomial. We can also look at adding polynomials by using a vertical solution. So when we're adding polynomials using a vertical solution, we're rewriting the problem so that the terms line up. So the first polynomial, 3x squared minus 3x plus 2, we'll write that above, and then underneath that we're going to add the other polynomial of 2x squared. I'm combining the like terms, so when I put them in a vertical solution, I make sure that the degrees, the terms, are like terms and they are in the same appropriate columns. So I'm going to write plus 7x and minus 4. Now that we have this vertical setup, we can add going straight down. For the first column, 3x squared plus 2x squared, that gives us 5x squared. Then minus 3x and a plus 7x. The vertical solution there is a plus 4x by combining those like terms. And then the plus 2 minus 4 is a minus 2. So our solution, when we're adding those polynomials using a vertical solution, can be written in this way. Let's do the next example in the same sense. We have 4x cubed plus 4x squared minus x and plus 2. We're adding the second polynomial, which starts off as a negative 7x squared. So I'm going to make sure that I put that polynomial, arrange it so that the columns have the same variable with the same exponent. So I'm combining like terms. And then plus x and the minus 5. We can add these together going straight down. There is no other x cubed term to combine the like term with 4x cubed, so that's part of our answer. When we combine the x squared terms, we have a positive 4 and a minus 7. That gives us minus 3 x squared. Now here we have this minus x and a positive x. That's going to cancel out to 0. We don't need to put the 0 there. We can leave that as a blank. And then plus 2 minus 5 is minus 3. So our final solution, we can write it as 4x to the third minus 3x squared minus 3. You can subtract polynomials as well. Be careful when subtracting and making sure that you're subtracting each of the quantities and not adding them. So when we're subtracting here, you want to make sure that you're subtracting from the first trinomial. You're subtracting an x cubed, you're subtracting a positive x, and you're subtracting a minus 8. So what you can do is rewrite the problem 3x cubed minus 7x plus 2, and then make sure you apply that subtracting each of those terms. So you can write it as minus x cubed minus a plus x is a minus x, and minus the negative 8 gives you a positive 8. And then we can combine like terms. First we'll combine the cubed terms. These both have the same power of 3, so we can combine those to get 3x cubed minus an x cubed gives us 2x cubed. And then we can combine the linear terms, the minus 7x with the minus x. We have minus 7x minus 1x is minus 8x. And then we can combine the constant terms, the plus 2 and the plus 8, and that will add up to 10. So that will be our final answer when you're subtracting polynomials. Make sure that you're subtracting each of the terms instead of just subtracting the first term. We can subtract polynomials vertically by writing the first polynomial above the second, lining up the terms in the columns. We have 3x cubed minus 7x plus 2 and x cubed minus 8x minus 8. Now we are subtracting the entire quantity. So we're subtracting the x cubed, so we write it as a minus x cubed. We're subtracting the plus x, so we're writing it as a minus x, and we're subtracting the negative 8, so we're writing that as a plus 8. And then we can do the vertical combining. 3x cubed minus an x cubed, that gives us 2x cubed, minus 7x minus another x is minus 8x, and 2 plus 8 is 10. So that would be our final answer, writing it using the vertical form.